So here we're going to look at some applications to systems of equations, aka your old word problems. Remember to mark the text or label the text. Also identify your variables and then always answer these as a complete sentence. So Kristen spent $131 on shirts. That's a lot of money. Fancy shirts cost $28. And plain shirts cost $15. If she bought a total of 7 shirts, how many of each kind did she buy? Here's our sentence, here's our question, what we're trying to answer. So actually, it might be best to start right there. We know that we need to answer that question as a complete sentence, so we could write, she, or Kristen, bought blank. How many of each kind did she buy? What kind of shirts are there? There's fancy shirts. She bought blank fancy shirts. And I don't know how many yet. That's what I need to find out. And blank plain shirts. If I knew those values, I'd put them in right there and I'd have my sentence answered. Bada bing, bada boom. But I don't know how many fancy shirts are. That's an unknown, so that'll be a variable. I'm going to have F equal the number of fancy shirts. And P be the number of plain shirts. Now we have 2 variables, so we'll need 2 equations to be able to narrow this down. So, well, I know she spent, if we talk about money here, she spent a total of 131 bucks. Now that was with buying some number of fancy shirts plus some number of plain shirts. Every fancy shirt that she bought set her back 28 bucks. And every plain shirt she bought set her back 15 bucks. So here's one true equation given from what we know. We also know that she bought 7 total shirts. Now F represents the number of fancy shirts she buys, and P represents the number of plain shirts she buys. So when we add the number of fancy shirts plus the number of plain shirts, that needs to equal 7 shirts. So here is a system of equations using the factual information we were given, and this will help us figure out, I think from here we can figure out how many fancy shirts she bought and how many plain shirts she bought. Actually, I know that we can do it, but it should work. So you have 2 options here. If you were into what we did last week, into that elimination stuff where we try to get opposite F's or opposite P's, you could either multiply this bottom equation by negative 28, or you can multiply the entire bottom equation by negative 15 to get rid of the P's. Or some of you have taken to this substitution thing, but in substitution we need one of the variables isolated or all by itself. And we don't quite have that here, but we could simply solve for F by subtracting P. So a third true statement is the number of fancy shirts is going to equal 7 minus P, minus the number of plain shirts. So if you want to do the substitution method, make sure you have a variable solved for. And then we would hug the 7 minus P and put that in place of F in that equation. Do some distribution, combine like terms, solve for P in this case. So it's totally your choice how you want to solve this. If you're not sure how to solve it, you could go back to your notes or the videos on 7.3 or 7.2. Let's try setting up another one. There are 13 animals in a barn. Hope they're nice animals. 13 animals. Some are chickens, some are pigs. All right. There's 40 legs in all. How many of each type are there? So here's my question. I'm putting that in a box. And let's go to trying to answer that question. So we could say there are, well, we don't know how many chickens there are, but they want to know how many of each type. So how many chickens are there and how many pigs are there? In the barn. We don't know. So those are our unknowns. Those will be our variables. So I'm going to let C be the number of chickens. And P equal the number of pigs. So there's two unknowns. We should hopefully be able to make two equations there. All right, so here we have C is the number of chickens and P is the number of pigs. When I add them up, that's supposed to add up to 13. That's one true statement from this information. We also talk about the number of legs. We know that there's 40 legs in there. Well, each chicken has 2 legs. There's 2 legs per chicken. So take the number of chickens, multiply it by 2 to get the number of legs. And each pig has 4 legs. So take P, the number of pigs, and multiply it by 4. That'll get you your number of pig legs. When you combine the chicken legs and the pig legs, you get 40 legs. From here, folks, we can figure out how many chickens and pigs there are. Your options are to multiply the top equation by just the top equation. I'm just going to bracket this because that is our system of equations. You can multiply the top if you wanted to cancel or eliminate the chickens, multiply everything by -2. If you wanted to cancel or eliminate the pigs instead, multiply everything by -4. Or if you wanted to do some substitution, you could solve for either one of these variables, actually any one of these 4 variables that you see. It's easier to solve for C or P in the top equation. There's less you have to undo. So if I wanted to solve for, let's say, C in the top equation, there's my top equation. If I want to get C by itself, I have to undo adding P. So C equals 13 minus P. Now we'd give that 13 minus P a hug and plug that into our other equation for C. There's our substituting or substitution method. It is totally your choice. Any of those methods, as long as you simplify carefully and do your algebra correctly, will give you the correct number of chickens and the correct number of pigs. Maybe not necessarily in that order. Let's try one last one here. Setting one up here. Farmhouse shelters 10 animals. Some are pigs, some are ducks. Altogether, there's 36 legs in there. How many of each type are there? What kind of animals are they talking about? How many pigs and how many ducks there are? So our final answer will say there are, and then we'll know the number of pigs, and there are blank ducks. In the farmhouse. Alrighty, so I don't know how many pigs there are. That's an unknown, so I'm going to say P is the number of pigs. And I don't know how many ducks there are, so I'm going to say D is the number of ducks. Got to be careful there. I made my D capital and it looks kind of like a P. That's no good. So I got 10 animals. When I take the number of pigs, P, plus the number of ducks, D, it needs to add up to 10. Talking about legs, there's 36 legs. If I take the number of pigs and multiply that by 4, that gives me the number of pig legs. If I take the number of ducks, D, and multiply that by 2, that gives me the number of duck legs. When I add the pig legs and the duck legs, I should get 36. I'm going to choose to solve this one by substitution, but if you wanted to instead multiply the top equation by -4, you'd eliminate the p's and be able to know the number of ducks. If you multiplied the top equation by -2, you'd eliminate the d's and be able to solve for the number of pigs. And once you know one of the animal types, subtract that from 10 and it'll give you the other animal type. In other words, plug it back into this top equation because that top equation is easier to solve. Speaking of solving, I'm going to instead choose to use the substitution method. So I'm going to take this top equation, p plus d equals 10. I'm going to solve for d in this case. So I'm going to subtract p from each side. So the number of ducks equals 10 minus p. 10 minus the number of pigs. And that makes sense. Like if there's 6 pigs, plug in 6 for p, that means there's 4 ducks. Yeah, that adds up to 10 and it works out. It's truthful in this. So now I have a variable isolated. So I'm going to take this 10 minus p and plug it in place of d in the other equation. And I'm going to do that work off to the right here. So I'm using this equation, 4p plus 2, not 2 times d, 2 times 10 minus p equals 36. So from here we distribute. So I'm trying to simplify this left side. There's a lot going on. So I have 4p plus, and then I distribute 20 minus 2p equals 36. Next we combine like terms. So I have 4p minus 2p. That equals 2p. And now we just undo what's being done to p. So we undo the adding first. So 2p equals 16. So if I double the number of pigs I actually have in the barn, I'd have 16 pigs. I want to undo doubling it. So I have 8 pigs in the barn. Then you can either use like this top original equation. So the number of pigs plus the number of ducks equals 10. So there's 2 ducks, right? Or you can plug p in right there. So the ducks equals 10 minus pigs. Ducks equal 10 minus 8. Ducks equal 2. So there are 8 pigs and 2 ducks in the barn. And if we take 4 times 8 pigs plus 2 times 2 ducks, I hope we get 36 legs. I'm just checking in that bottom equation, and yeah, we do. So I'm really confident in that answer. That's exciting.